This question belongs to engineering mathematics subject and was asked in GATE CSE 2015. So the question states, let G equals to V comma E be a simple undirected graph and let S be a particular vertex in it called the source. So we have source vertex represented by S. For X belongs to V, let dx denote the distance of in G from S to X. So from source S to any vertex, let us suppose X, the distance is denoted by dx. Okay, a BFS is performed starting at S. So we have a graph G and we are performing BFS starting at the node S, which is the source node. Let T be the resultant BFS. So we get the BFS tree. Tree T, BFS tree, breadth first search tree. If UV is an edge of G, if we have a edge UV in G, that is not in T, which means U and V are not connected in T, then which of the following cannot be the value of du minus dv? Okay, so we can do this easily with the help of counter examples, okay, or with the help of examples. Okay, so first let us consider a diagram like this: S, U, V, and X. So see, S is the start node, source, and so what happens? Now see, what is du? Du is the distance from source to U. It's 1. What is dv? By default, every weight should be considered as 1. It's default in case of graphs. What is dv? dv is 1. So, and what is our BFS? BFS will have S, U, V, X. It can have like this. So BFS don't have UV. And what is du minus dv? It's 0. So 0 is possible. Okay. And why this happens? So the case of 0 occurs when both u and v have an edge from a common node T. So we have a common node and both u and v have an edge from a common node. And u and v are also connected. And T is the shortest. T comes in the shortest path from S to U to V. So in the shortest path, T comes to u and v. So this is the case that we have discussed over here. Now let us discuss the case for option B. Okay. So option B states that now we have, let us consider the case for 1 or minus 1. So consider graph like this: S, U, V, or make it as X, V, U. Okay, perfect. All the weights are 1. Now see, now what is our du? Du is distance from S to U, it's 2. dv is 1. And what is our BFS? BFS won't have UV edge. So BFS can have edge like this and UV won't occur in the BFS. And what is du minus dv? It's 1. So 1 is also possible. And what is, and if we replace, see here, if we can replace u and v, then also same case will occur. Here we will have v, here v, and here u. Okay, then du minus dv is minus 1. Okay, because in case du is 1 and dv is 2, so du minus dv is minus 1. So 1 and minus 1 are possible. And when this case occurs, so du minus dv, one case or minus 1 case occurs when v and another node t. So we have v and another node t. So let us suppose like this: we have source T, V, and U. So it occurs when V, which is this one, and another node T are in the shortest path from S to U. So from S to U, both these should come. So from S to U, both T and V should come in between. Okay. And both T and V must be siblings, which means they have same distance from S to both T and V, causing TUH to be in BFS tree and not UVH. So TUH will be there and not UVH. Okay. Now, what is du minus dv? equals to 2. Will this case occur or not? This case is not possible because the BFS, see we have a BFS, so either first we will visit U or we will visit V, and we have a distance from U to V. So while traversing DFS, either we will first visit U or we will first visit V. Now in either case we will put all the neighbors of U. Suppose we visit U first, then we put all the neighbors of U first. So in those neighbors V will also come. Since V is a neighbor and V is not visited before, if we assume, then V will come in the next iteration, and in that case they will have a distance of 1 and not 2. 2 is not possible. 2 would be possible if U is not a neighbor of V and is connected to 3. Then 2 is possible. But as U is our neighbor, so 2 is not possible. So we need to tell which of the following values cannot be possible. So A, B, C and are possible and D is not possible. So answer is D. 2 is not possible. Option D.